Okay, this video covers the standard normal distribution, and I'm going to teach you how to find areas under the standard normal curve. So the standard normal curve is a normal distribution with a mean of 0, right here, mean of 0, and a standard deviation of 1. So the mean is 0 and the standard deviation is 1. There are infinitely many normal distributions, each that have their own mean and standard deviation, but this is a special normal distribution with the mean of 0 and the standard deviation of 1. Every normal distribution can be transformed to the standard normal distribution, and the reason why we do that is because we use these values right here on the x-axis, which are called z-scores, to find corresponding areas under the curve. The areas under the curve lead us to probability. This helps us find x values and probabilities that are really relevant to real-life problems. When we find area under the normal curve, whether it be a regular normal distribution or the standard normal distribution, we are always finding cumulative area starting from the left. And so in the previous video we talked about how the area under the curve was equal to 1, and at the mean the area under the curve was equal to 50% or 0.5. This cumulative area starts from the left and goes to the right. So properties of the standard normal distribution are that the cumulative area is close to 0 for z-scores close to negative 0.349. So if you recall, when we're dealing with the empirical rule, 3 standard deviations away from the mean, both to the left and the right, contain 99.7% of the data. Well, if we're going another almost half standard deviation away from the mean, then it's way over here, and if we're going from left to right for cumulative area, this covers nearly nothing. The area under the curve is nearly 0. So since we're finding the area under the curve going from left to right, the area increases as these z-scores increase. So I don't know if I mentioned this. I don't think I did. Z-scores correspond to standard deviations. So 1 standard deviation to the right of the mean is a z-score of 1. 2 standard deviations away from the mean is a z-score of 2. So as we're going from negative infinity z-scores to positive infinity z-scores, the area under the curve is increasing. The area for z equals 0 for a z-score of 0 is equal to 0.5 or 50% of the curve. And the cumulative area is close to 1 for z-scores close to 3.49. So 3.49 is about here, and that's about an area of 1 or the entire area under the curve. We're going to use something called the standard normal table to find areas under the curve given a z-score. This table was used before we had calculators that were able to find the areas under the curve for us. So I'm going to show you how to use the table because that's how we used to do it, but I expect you to use your calculator to find these percentages, to find these areas under the curve. So this is what a standard normal table looks like. What's happening here is we have z-scores that are in this column, and then z-scores in this column. The z-scores here are 1 decimal place, and the z-scores here are 2 decimal places. So you combine these if you wanted to find the area under the curve for a z-score of negative 4.05. What you would do is you would take negative 0.4 and 0.05, and where those two intersect would be your area under the curve. So let's use the table to find the area under the curve. If if I want to find the area that corresponds to a z-score of negative 0.44, what I do is I go over to my table. I find negative 0.4 and 0.04, and where those intersect right here is my area under the curve. When I do these problems, the first thing I want to do is I actually always want to sketch my normal curve and the z-score that I'm interested in, and then shade the corresponding area. So in the normal curve, this is 0, the mean, and negative 0.44 is about here. So I'll shade that in, and this is what I'm interested in. So I found that that area was 0.330. Now, I want to show you how you're going to use your calculator. Okay, I'm going to show you how you use your calculator to find the same value. So here I have my curve and negative 0.44, and I'm trying to find this area. Well, when I put it into my calculator, I need to give my calculator a interval where the z-scores are. So since this really starts at negative infinity, because it never ever touches the x-axis, my interval is going to be between negative infinity and negative 0.44. So in my calculator, what I do is I go second distribution, and go to normal CDF, not normal PDF. Normal CDF stands for the cumulative area. So you're going to do normal CDF, and you're going to put the lowest value, comma, the highest value. Well, we can't really do negative infinity. So what I like to just do in my calculator is negative 10,000. It's close enough for me, and the calculator will understand what you're doing. So negative 10,000, comma, negative 0.44. I close my parentheses, press enter, and I have that same area. This one is actually a little bit more accurate. It gives me a lot more decimal places, but because in this class we're rounding to 3 significant figures, it ends up being the same thing as 0.330. Okay, we'll do another one with your calculator. We want to draw, we want to find the cumulative area that corresponds to a z-score of 1.15. Well, here is my mean at 0. 1.15 is to the right of the mean of 0. And I want to find the cumulative area under the curve. So what I'm going to do is I'm going to put into my calculator normal CDF, negative 10,000, comma 1.15. And I didn't mention this before, but you should always draw your standard curve and write down what you're putting into your calculator. That way, if your answer is wrong, if you write down what you put into your calculator, you could potentially get some points for putting some of these values in here correctly. So we go second distribution, normal CDF, negative 10,000, comma 1.15. And I get the area of 0.875. So you would write, you can write your final answer as a decimal, or you can write it as a percentage. Either way. Some other examples. For this one, we want to find the cumulative area that corresponds to a z-score of negative 1.12 to 1.6. So here we have an interval that we want to find the area of. So if this is 0, this is the mean. Negative 1.12 is over here, and positive 1.6 is over here. And I want to find the area under the curve that corresponds to this. So I'm going to, in my calculator, do normal CDF, the lowest value, which is negative 1.12, comma, the highest value, which is 1.6. When I put that into my calculator, I get 0.814. In this problem, I want to find the cumulative area that corresponds to the right of 2.3. So 2.3 is all the way out here, and I want to find the area over here to the right of that. Well, remember, your calculator can only calculate area to the left of a z-score. So what you have to do is do normal CDF. You're going to do negative 10,000 to 2.3, and I get 0.989 and that area corresponds to what I'm coloring in red. So this area in red is 0.989. Well, if I want to find the area that's in blue, all I do is 1 minus 0.989, and I get the area that's in blue, because the total area under the curve is 1. So the area in blue, the answer to my question is 0.011. So last thing, some guidelines for doing these problems is you always want to sketch a curve and shade the appropriate area under the curve. If you're using a table, you want to find the area that corresponds to the z on the standard normal table. And if you're using a calculator, you want to use normal CDF, the lowest value, comma, the highest value in your interval. Good luck on the practice problems.